Hi, Maynard King again. This video is specifically for the guys at Ranger Lake. Your system is a little bit different than the one that the longer video for Cache River outlines. Your system does not have all of this equipment here. It doesn't have the contact tank, the pre-filters, and doesn't have the two chemicals being injected or anything like that. So what's your system operating like? Your water basically comes straight in to the membrane system. So you have the pre-filter, which you need to change. You turn off these two valves, press the red button until all pressure's gone, and now you unscrew that using the filter wrench. How do you know that your filter needs to be changed? You'll either get a low inlet pressure alarm, the red one here, or you'll see a huge difference between the pre-filter inlet and pre-filter outlet gauge. I mentioned in the Cache River video that their membrane system operates at around 900 psi on the membrane feed. That's because their water is so high in salt. At Ranger Lake, your water is kind of brackish water. It's only got some salt in it. Your system operates between 400 and 500 psi. So it's only half the pressure you're running at, and you only have one membrane, whereas they have three here. But other than that, look at the Cache River video for operation. Same thing, aim for 0.25 gallons per minute or so, 0.25, 0.27, and use this valve to adjust that. And don't worry if the pressure goes up to 600, but I should mention that if you notice the pressure constantly climbing in order to get that 0.25, that might tell you that the membrane is starting to clog. Other than that, please look at the Cache River video for help on this control panel and some of the alarms. They are all the same, so just skip ahead in the Cache River video to the part where I talk about this skid, and that'll help you with any troubleshooting. Other than that, give me a call at 709-730-5557, Maynard King. Thank you. After it leaves the carbon filter, now we inject another chemical, and this one is antiscalant. And the job of the antiscalant is to keep the different salts and metals and scale from forming on the membrane system. So it's basically a food safe chemical that keeps the scaling from forming on the membranes. After we inject the antiscalant, it goes through a pre-filter. In this should be a 5 micron filter. And that's basically one of these right here. It's a 5 micron filter, and it needs to be changed once in a while, and I'll talk about that in a minute. To change that filter, there's a wrench here that you put on the bottom of the blue thing. It only fits up about that far, but then you can twist it and undo that. It's basically, this is threaded onto the black piece. But before you change it, of course, what you need to do is release the pressure that's in it. So to change the filter, you shut off this valve, you shut off this valve, that's the inlet and outlet, and now there's a red button right up there on the top. You press that red button and water's going to squirt out, but the important thing you're doing there is you're releasing the pressure. And that makes it a lot easier to take this off and make sure you don't get so much water spraying out at you. So close inlet and outlet, press the red button until the water stops coming out, and it's very difficult not to spill water. So I recommend you stand on a chair and get this thing and put underneath like that, and then unscrew the filter and try to catch it when it comes off, and it's going to be filled with dirty water. So you want to try to hold on to that and move all of this together. And now bring this, and you can empty the water in the toilet, empty that out in the toilet, and the filter can go in the garbage, and you pop your new filter in. When you put in the new filter, the yellow, just on this brand anyway, has to be on top. And you can see that because the bottom has like an indent, but it's plugged. So this one, the yellow faces up, it sits in the blue housing, and then you just screw it back on. The way the blue housing seals to the black part, the top, is there's a large O-ring there. Make sure that that O-ring is in place nicely so that when you screw it back on, you don't get any leaks. After it goes through the inlet filter, which filters at the 5 micron, it basically is going to this skid. So this is a reverse osmosis skid, and it's got 3 membranes, and it's basically, the reason why it has so many membranes is because it's very difficult to filter out the salt that is in your water. You've got basically seawater coming out of your well. It's so high in salt that it's pretty well seawater. So what a reverse osmosis membrane actually does, it's so fine that it actually filters out salt molecules. So going into the filter is salt water, coming out is fresh water. And it will remove pretty well 90% of the salt that's in the water, leaving only a tiny amount left over. The way the system works then, after this system, which is loud when it's running, because it has a very high horsepower, very high pressure pump, so it's nice and loud. So as it's running, the product water, which we call permeate, comes out of this tube and goes into the large tank. While it's running, it also sends a constant waste stream. So coming out of this tube, the one that goes horizontally, basically that tube goes to drain. So while it's running, it only makes around 0.25 gallons per minute of good water, and it's throwing out around 2 gallons a minute of wastewater. So these things are water hogs. They waste a lot of water, but it's the only way to get salt out of water, except for evaporation. So if we didn't have such a high waste stream going to drain, the salt will basically build up on these membranes and clog them. So it's important that the waste stream is always going to make the product water. So basically, we're only making 0.25 gallons per minute, which is a very small flow. When you think that a tap has around 5 gallons a minute that can come out of it. So it's important that we have a lot of water storage, and that's what this tank is. This tank contains 600 liters, that's like 225 imperial gallons, 270 US gallons in it. So it's a fairly heavy tank. And what we do is there's a level switch way up on the top. If you look way up on the top, you can see a gray piece of 1/2-inch Schedule 80 pipe. On the end of that pipe, only about 8 inches down, is a little float. It's a single level switch. So that level switch, as soon as it drops, the system will start up. So it won't wait till the tank is half empty. As soon as that level switch on the top drops, the system will kick in and it'll start making water. Why? Because it takes a couple of hours to make this much water in the tank. So it's important that we have a lot of water storage. So if you use a lot of water at this facility, you could empty the tank halfway down. If 3 guys get a shower and someone does laundry, the tank might be half empty. But then it'll take a few hours to fill it back up until it's full again. So that's why we have so much water storage. So this pump draws the finished water then from the finished water tank. So its job is to take water from this connection down here, right at the bottom, through this 1-inch valve, through this 1-inch hose, and send it to the facility. So it's an automatic pump that you don't need to do much with. You can turn the pressure up by hitting this up arrow right here, and you can turn the pressure down by hitting this down arrow. There is a start and stop on the pump. So if I hit that, the word stop comes up here. So if you see that word stop, the pump is not running. And if you turn on a tap, pressure will just drop and no water will flow. So if you do ever open the tap and no water's coming out, you might want to check there first to see if the word stop is there, or to see if the pump is unplugged or something like that. It's just a 110-volt pump that's plugged into a receptacle. So to start the pump again, you just hit the power button again. The word stop goes away. So the pump runs on demand. Basically, when someone turns on a tap, there's only a tiny little pressure tank up there on the wall that only stores about 1 gallon. And once about 1 gallon comes out, this pump will kick in. And it's called a constant pressure pump, which means it'll run to maintain pressure to your system. So it doesn't turn on for 5 minutes and stop, and then you keep running water. As long as you're running water, the pump will probably kick in and out and maintain a constant steady pressure to the tap. That's what we call a constant pressure pump. The pump is a self-priming pump. So like any self-priming pump, if you ever have the system drained and you need to start it up again, it's very important that you prime the system. There's a plug here for priming that you take out and fill it. But I should note that if the tank is filled with water already, permeate water, all you really need to do is loosen this plug, and the head pressure in the tank will flow through the hose, work its way up the pump, and it would actually overflow here if you don't close the plug quickly. So it's an easy system to prime because it's got some head pressure. Other than that, it goes right to your system, and that's it. So that's the layout of the system here in Cache River. Now, I want to talk a bit about the reverse osmosis skid. So when this skid is running, it sounds like a compressor. It's a pretty loud system. It's because it's got a kind of a hydraulic type pump, a piston type pump, which makes a lot of noise when it runs. So it's recommended to keep that door closed so you can sleep if it's running. There's a control panel that governs the whole system. So basically when the system runs, we have a bunch of gauges here that will read pressures. The first one is the pre-filter inlet pressure. That is the pressure coming into the blue filter up top. And the second one is pre-filter outlet pressure. And that one is the pressure coming out of that filter. So remember earlier I talked about the 5 micron filter that goes in the blue housing. If you see a large difference between these two, that's a pressure drop. That means that this filter up there is plugged and it needs to be changed. So the pressure will normally fluctuate up and down between like 20 and 40, and all that is the well pump kicking in and out. But the important point to note is if you see 30 on the inlet, but you only see 20 on the outlet, that's a pressure drop. That means your filter is probably plugged. But if that filter is plugged, you'll probably get an error anyway. Down on this control panel, there is a red alarm called low inlet pressure. So if this one comes on, it means that there's not enough water supply coming to the system. So either somebody turned off a valve, or the well pump is down, or that filter up there is plugged. So if you see this red light, you need to rectify why is there not enough water pressure coming into the system. And then once you've got that rectified, you can reset the alarm right here. There's a reset button. So that goes for any of the alarms, by the way. There's a reset button for most of the alarms that you would see, except for RO pump motor fault. So just back to when the system is running. So when it's running, you will notice these two pressures here. The membrane feed pressure is the pressure coming out of the high pressure pump. For Cache River, that runs at about 800 to 900 psi, and that's because you have pretty well seawater coming out of this well, so it takes a lot of pressure to put it through the membranes. And to give you an idea, your normal pressure in a house is 40 to 60 psi. So we have to actually pump that water to 900 to push it through these membranes to get fresh water out. The concentrate pressure, that's basically a back pressure that we put on the drain that I was talking about earlier. And so you'll see that this one is a little bit lower. So this one might be around 700 to 800, while the membrane is 800 to 900. So if you see the membrane pressure going to 1,000 or so, you might want to back off the pressure. And the only control that you have on the whole system is this one valve. It's a needle valve, and it's called the concentrate recycle valve. Basically, the more I close this valve, I'm pinching off the drain, which puts more of the pressure to the system. So both gauges will go higher when I close this valve. Both of these gauges will go lower when I open this valve. And also you'll see the flows change. So what is important for you to do is to keep the membrane pressure below 1,000. If it's approaching 1,000, back this off a little bit. And the other thing is you'll see your concentrate flow and permeate flow. So basically there are two flows for the system. One is the amount of water that we're making. This one called permeate is the product water. It's the water going to the storage tank. This one would normally run around 0.25, which is right here. So on the left side, you'll see 0.1, 0.2, 0.3. So only around 0.25 gallons per minute right there is where this float will be. And you read the float at the largest part. So if I close this valve and put more pressure to the system, this will climb. And you can't really operate at around 0.4. If you do, the pump will trip and things like that. You really need to be between 0.25 and 0.3, and if you find if the system is tripping out at you, just keep it at 0.25 gallons per minute. So you'll notice that the concentrate flow, this is basically our waste that we're putting out. I told you that we're wasting a lot of water as we make good water. So this one normally runs at around 2 gallons per minute, and you read this one at the top of the float. So the top of the float will be around 2 or a little bit lower, and you'll see that the more I close this valve and put more pressure to the system, this one will drop a little bit, but not a lot. Normally it stays around 2 gallons per minute. So the important things for you to look at when it's running, just to do a check on the system, is what is my permeate flow, which is the water I'm making, and my membrane feed pressure. So adjust this black valve to keep your permeate flow around 0.25 and your membrane feed pressure below 1,000. And you'll notice the gauges move as soon as you start tweaking this valve. And it's not a constant adjustment, it's just an adjustment that you should check on every now and then while it's running. You can only do it while it's running. Check on it to see that those parameters are around there. So let's talk about how the system is turned on and off. It says RO system, hand, off, auto. Basically, the normal operating position of this switch is in the auto position. And when it's in auto, it'll basically follow that level switch that's in the tank. So the level switch drops, it'll automatically kick in. That's why it's called auto. If the level switch crapped out, not working, and water's dropping in the tank and you got no water, you can actually flip this switch over to hand to force the system to run. And it'll run and it'll start making water. However, what you got to remember is that it will also overflow once the tank gets full. So until someone gets a hold of me or the level switch is fixed or replaced, if you run it in hand, make sure you just don't overflow it. You fill the tank up and then turn it to the off position. But turning it to the off position at any time stops the whole system. Nothing will run when it's in the off position on this control system. Normal is auto. When the tank fills, it gets to the full position where the level switch float goes up, and it'll actually run for another 20 minutes after the level switch is up. And at the end of that 20 minutes, it'll do a flush. That's when this light turns orange. And the flush basically takes some good RO water from your taps and floods it through these membranes to get rid of the salt and the sediment that might be on the outside. So that flush lasts only a couple of minutes. Once the flush is over, the blue light comes on saying the permeate tank is full. And then it'll stop. And it won't do anything again until water is needed. The other lights that are here, chemical tank empty. If either the Javex or anti-scalant tank goes below the level switch, this will light up. So if you see this light, it means it's time to refill chemical. And I'll talk about the chemical pumps in a minute. This light, pre-treatment lockout, if either of those filters I talked about earlier, the Culligan filters, if either of them goes into a backwash at 2 o'clock in the morning, then the pre-treat lockout light will light up as long as that backwash is occurring, so that the system doesn't try to make water during a backwash because it has no water supply. And the last two lights, RO system run. Whenever the system is running and that loud pump is going, RO system run is lit up. And the last one is RO pump motor fault. Inside this panel, there is an overload relay, and I'm going to show that to you in a minute in another video. If you see this red light lit up, you need to open it up.